Good morning. Welcome to our talk on desalination in Corpus Christi. I am Dr. Christine Parasevich. I'm one of the economics teachers here. One of the things that we do every year is we look at a community issue so that you can try to relate your economic studies to something that's going on in the community. So one thing that is beginning this year, after many, many years of everyone in the state thinking about it, talking about it, hoping about it, is that the City of Corpus Christi has begun a project to look at desalination plant in the city. So Mr. Esteban Ramos, Steve Ramos, is our guest speaker today. He's the Water Resources Manager for the city. He's a graduate of Texas A&M's Bioenvironmental Program. And so we welcome Mr. Ramos. At the end of his presentation, we will have questions and answers. Please ask them loudly. Please ask them. Thank you. Mr. Ramos.
Thank y'all for having me. I really appreciate this opportunity to come and talk about water resources and about our community. What I'm wanting to kind of walk y'all through is give y'all an idea of our raw water supply, where it comes from, how the city of Corpus Christi uses it, talk about a little of our where those sources are so you have an idea. You can always think about water as a economic driver. I kind of always, when I talk to different community events or people on the street, you know, we take water for granted. We think about it as, oh, it's not there. We always, in the place where we live in the United States and our economic wealth that we have, water is expected to be there no matter what, all time, 24 hours, 7 days a week, in a hurricane, in a drought, any single time of the day. We take it for granted. But there's a lot of work and a lot of economics that goes behind it that drives. It's the lifeblood of a city. It's the lifeblood of a state. But we always take it for granted. There's always talk, a lot of talk from the top down, from our political, from the national level to state level to local level when there's a drought situation. And then when it rains, everybody goes back and says, okay, these big projects, these multi-$100-million projects that span environmental issues, expand new technologies, expand how construction science. Everybody kind of like, okay, well, wait, we did a lot of the planning. We'll take care of it when we need to take care of it. And so I wanted to kind of introduce y'all, kind of walk y'all through what the city of Corpus Christi, what our water resources outlook, how we use our water, where our water comes from. So that's going to kind of be the theme of my presentation, and then I'll go through it. We'll talk about the different water strategies that the city of Corpus Christi has invested in and projects that we're going to continue into the future. So our city of Corpus Christi, we are the regional water supplier for nearly about 500,000 people in the coastal bend. The city of Corpus Christi itself is around approximately 347,000, depending upon the different census data that you get. We have probably about a 1% growth. So our population growth isn't really truly the big driver in our water demands. Our sources of water, we have 4 sources of water that feed our region. We have Lake Corpus Christi, Choke Canyon. We have the La Vaca Navidad River Authority has a lake out there called Texana. We purchase water from Lake Texana. And then we also have water rights. I'm not sure how to do this, but, well, we have water rights in the, sorry about that.
That's okay. Usually it's right.
Okay.
You know what? Why don't you?
I'm a talker. I like to walk around, so it's kind of like, forgive me. My parents were teachers and stuff like that, so I kind of get it from them.
Oh, this one isn't plugged in, but I'll do that.
I got it.
You can do this. Okay.
Thank you. And so the important thing is when you're looking at this map is the diversification of the geographic area that I want to point out. Thank you.
Push that one and that one.
Okay. So we have we have these sources of water out here in the Nueces Basin, which is a large area. So the state of Texas has approximately 23 river basins. And then within those river basins, there are sub-basins. So the Nueces Basin is this big area. It goes all the way up into the hill country of Texas, kind of the Concan area. Very pretty. If you go up there, love camping, you'll see maple trees, you'll see big pine trees, big cypress trees. It's a whole different type of world from where we live here on the coast. Very, very dramatic. But we have two major reservoirs that take water from this big watershed and capture it in these reservoirs. We have Choke Canyon, which is fed by a sub watershed of the Nueces called the Frio River watershed. It's a lot smaller than this area, but it mainly gets its water from the Frio River that feeds into Choke Canyon. Choke Canyon is a very large reservoir. It's about twice as large as Lake Corpus Christi, so a little over 600,000 acre foot. And you can imagine an acre foot is 1 acre, 1 foot deep. In gallons, it's 325,851. So it's a lot of water. The Lake Corpus Christi is the older water right reservoir on the Nueces. That reservoir is approximately around 256,000 acre feet of water. It has a large area. At the same time, I don't know if everybody's heard of the Edwards Aquifer. You go to San Antonio, it's a large aquifer under the ground. That area of the Edwards is in this area. So you have a lot of flow that's in this area that seeps naturally into the Edwards Aquifer and recharges that area. So what we tend to see filling Lake Corpus Christi is rainfall in this general area, kind of the Cotulla, Tyndall area, that if we get a large rain event like we just had this past couple of weeks, and then crossing the fingers, hopefully continues into this weekend, where we would see a large amount of flow coming into Lake Corpus Christi. This time of year, September, October, is our most rainiest part of the year. You would think it would be more springtime for us, but it's actually this time. Big reason, historically, hurricanes, tropical storms, either coming up the Gulf or on the Mexico side, coming through the Pacific, across the big mountains. And they'll drop a ton, either drop like a wave that comes up and then causes a cold front, basically a line of disturbance between the wind, and it will stall in this general area. And that's where we get the big rains that fill our reservoirs. We use these reservoirs as a kind of a balancing system. One can release water to another, and then we divert water kind of in, Calallen area. That's our diversion point. So we need to have water, we can capture water here, we can move water from here to here, and then we can release water to our diversion point for the city of Corpus Christi in this general area near the Calallen, or Owen Stevens water treatment plant. The city of Corpus Christi only has one water treatment plant that feeds our entire region. Then we have the Mary Roads pipeline. It's about this, there's two phases. We always kind of talk about it in phase 1 and phase 2. The economics behind that, the first part was approximately about $116 million construction cost for that pipeline. We purchased water through Lavaca Navidad River Authority out of Lake Texana and then we put it into this big pipeline, which I could stand in. That's how large the pipe is, and carry water all the way down to Owen Stevens treatment plant. Then we have phase 2 of the Mary Rose pipeline, which was kind of completed in about 2016 timeframe. We, at a cost of about $156 million. That is approximately 41 miles. And then that brings water from the Colorado River. So if you go up to Austin, all that water flows down to a point near Bay City. And then we divert water from there, and we take water all the way to our Owen Stevens treatment plant that feeds our region. So you can see big economic costs in construction, environmental easements, land acquisition. All that goes into doing a pipeline and taking care of a pipeline. Because one, I just said the construction costs. So that's like you put it in the ground and you build it, right? But you still have O&M, operation and management of said pipeline, and in perpetuity. To give you an idea of the percentages, this area feeds about 60% of our daily use, and the other, from the Mary Rose, is about 40% of our consumption comes from that.
It's on move it forward. Yeah.
Okay. So, who are we? Who are our customers? Again, the city of Corpus Christi, we are a wholesale water supplier. We feed Sampat Municipal Water District. So if you go over across the area and you go to, say, Portland and Gregory on that side, they purchase water from the city of Corpus Christi, treated and raw water. The city of Alice, Beeville, Mathis, they all take from either, those three take from Lake Corpus Christi. We have also industries take raw water straight from the river, such as Flint Hills, Celanese, and then also we treat a lot of the water and sell it to the community, and then also our community industrial customers. Again, that is a major part of our whole kind of customer base for the city of Corpus Christi. So we have a very diverse portfolio. Kind of give you some customer demand projections. 2016, we're about 100,000 gallons of 100,000 acre feet of water. We're projected to see a big demand come in about 2020. And this is due to a major economic development in this area. The Exxon plant should come online the number always kind of changes. We're prepared for it by 2020, but it could be 2021, 2022 timeframe. 1 or 2 years, really, dealing with $1 billion project, you're going to see some variety in exactly when that date is going to be. But so we will see an uptick in the consumption of water. One of the things from a water supply perspective that we look in our planning perspectives is how much of what we call the use of a safe yield. Working with our state and local partners, we develop a safe yield concept. That means an amount of water that we save in our supply in case of the worst case drought could occur. That amount that we save would be about 75,000 acre feet. So using that number in our modeling, we look at a safe yield number of around 178,000 acre feet. So currently, with all the demands of those customers that I pointed out earlier, we're using approximately 59–60% of our safe yield water supply. With our projections for 2025 and the customers coming in, we would see a jump to about 75% of that safe yield. So what is, that's a long introduction to say what? This is the time to plan. This is the time that we get our community, we get everybody behind of thinking and acting on what is our next step. We're not going to run out of water. We're using our water. We have some that we can still deal with the drought, but this is the time when we need to start doing the right steps to plan for our future. Because we're going to go out to 2025, we're going to go out to 2050, 2070. Those are long dates that we need to plan for these types of big projects now. Every 20, 30 years, it's kind of communities look at bringing on a new water supply. So spending that, $100, $200 million on a water supply. For a city our size, we should always think about bringing something online in about 30, 40 years time frames. So this is the time to start doing it. We're kind of different than most cities because of the first part of what I was talking about our population and our economic drivers. Our demands and the changes in our demands come from the economic development, i.e. large industry. Community-wise, our population doesn't really grow as fast as you would think, like Austin or the I-35 corridor between San Antonio and Austin area, where you're seeing like 10%, maybe even 15% growth. I mean, crazy numbers like that. And that's why you have those big communities up there, such as SAWS, San Antonio Water System, doing large, big, billion dollar water projects. So we have to do what is best for our area. We have to think about what is best for our community and our community partners so that we can look at the economics, and the economics will fit in our area. The economics that are good here aren't necessarily the good economics that are somewhere else. So we've got to do that planning. We've got to do that work here today. From a treated water perspective, because again, a lot of our customers take a good portion of our treated water along with the raw water. But from our treated water perspective, we are industrial users in 2017 are about 46%, and our residential use is about 36%. The jump by the projections in 2025 for treated water, this is that big, customer coming online. Will be about the overall percentages will change, and it will be about 60, 70% of our treated water demand, and then our residentials would be about 20%. So it is going to have a change in who is using most of the water. But again, the city of Corpus Christi is responsible for our customers. It's like, we need to provide water to people that need to use it. And that's why we're here for that. So how are we going to meet those challenges into the future? What are the type of strategies that we've talked about? We work with, the state has what they call a bottom-up approach, the state water plan. It's a big encompassing 5-year document that talks about different water projects across different regions of the state. We are in Region N of the state water planning. Some of the strategies that this group, this Region N, and the city of Corpus Christi is a part of that, has looked into range from water conservation. Water conservation is always at the top because it's, looking again, economic driver is looking at the cheapest, most economical way of doing a water supply strategy. Conservation is always looked at first. Then we've looked at brackish desal, we've looked at potential other water systems, interconnections, maybe buying it from a local community. These are kind of the strategies that the region has investigated from groundwater, surface water to brackish desal. Then the city of Corpus Christi is also working with Region N, has also continued efforts on municipal water conservation, reclaimed wastewater, and I'll get a little more into depth about the reuse kind of aspects. We're looking at sources that are close to us, respect to groundwater through the Gulf Coast aquifer. And then we've looked at seawater desalination, and we started looking into a potential project in the past, about 2017, 2016, looking at a variable salinity kind of, that was kind of really a scientific project looking at the variations in the types of desal or salinity that a desalination project could potentially be built. Because in that project, and that was really a idea of looking at the salinity, because the salinity will tell you what type of equipment you will need, the processes that will be incurred in that train or the work to create a potable drinking water, and look at the different sciences and the technologies that one could, because it's kind of it's never apples to oranges. You're always going to get a variation, and that particular science study was going to look at the economics behind that. So if you're dealing with a lower salinity compared to higher salinity, how much and what technologies would you use or incur, and what would be the costs? So we went down and started to look at that. That was a project, and then we have done improvements to Owen Stevens water treatment plant to become more efficient, to be able to treat more of the water so that we can supply. And you can also see it helped. This improvements help dramatically with the water quality in our area. I started in late October, November of 2016. Before that, I was the South Texas and Concho Water Master working for the state of Texas with the TCEQ, and talking to different communities about how they can survive a drought, what they can do, water quality, what kind of efforts they can undertake. And the city of Corpus Christi, we're not going to hide it. We've been through those water boils. We've been through the water quality. It is part of our history, but I can tell you now, the amount of work the water department does is amazing. From then to now, it's night and day. The water quality in this area coming out of the Owen Stevens treatment plant is higher than it's ever been. And it's consistently there. And you can see a lot of the big construction projects that are going on. One of the major projects that we're having for that is the Holly tank. If you've seen that going down Holly Road, you see the big new water storage tank. That is going to increase the pressure in the city, which then therefore helps with the water quality. That's just one. And then you got the Rand Morgan tank coming near in the Morgan area, Cal Allen. It's a little smaller. It kind of looks a little smaller because it's kind of weird that you would think that is the highest point in the city of Corpus Christi in that area. So pushing water, you don't need to go that high compared if you're way down here, you're already up here. So that was kind of the will help and drive our good water quality and great water quality and improvements in our Owen Stevens water treatment plant. So water conservation, I kind of touched on this. This is always looked at first as a strategy and an economic strategy, because again, it's the most efficient, and you get the biggest bang for your buck when you do these type of efforts. and you start teaching people how to use water, and at the same time, you get them to start thinking about water all the time. You know, like I was talking about earlier, everybody just worries about water when they don't have it, and when they got it, they forget about it. But if we have good conservation communication, and it's a year-round effort, it always keeps water in the forefront of your mind. And so it will help reduce peak stresses on the system. It will help with the water quality. It will help with the whole understanding of, again, exactly where your water comes from and how you spend your water and how you use your water. So the city of Corpus Christi, we're in a great place. Actually, our residential gallons per capita, that's kind of like how much I would use on average. We're about 63 gallons per day. And that's real good. That is really good. We could always get better. City of San Antonio spending a ton of money to lower they're like in the 90s, and they want to get by the 20s, 2022, 2025, maybe around the 70s. And they're spending, you go up there and they're always talking about water conservation, and they have these big programs, and you would think they would be like, oh, we're really low off these numbers. No, they like their green grass, they like their pools, they like that kind of thing. So it's something we can be proud of, and I think, and really this is a response from, again, when we didn't have water in 2013. So the state of Texas went through a large drought in about 2011. Here in this area, the effects really didn't happen until the 2013 timeframe. Lake Corpus Christi, Choke Canyon were at all-time lows. The community at that time didn't do a lot of water conservation. And my predecessor and his group pushed water conservation a lot. I would invite all of y'all we have a xeriscape garden down near the Science and History Museum off of, I forget the road, but down there near the port area. It is an outside, kind of example of what you can do at your home and see the color, see the different varieties, different wildlife through good conservation and that you could apply at your home and still have a great, vibrant lawn and not use as much water as you think you would use. So it's a learning center down there. I started talking a little on reuse. The city of Corpus Christi has multiple water treatment plants, OSO, Greenwood, and we have looked at reuse. Reuse is there's two different types of reuse. One is direct reuse. That's basically when it goes through your water treatment plant, wastewater treatment plant, and then you reuse it again. You tap into the water coming out and you use it. There's two types of uses. Only one in the state of Texas. During 2011, when everybody was running out of water, there was what called direct potable reuse. And this was in Wichita Falls up north in that area, where they went through the TCQ process. This was new to the entire state of Texas to permit how you would take wastewater and put it straight back into your distribution system for human consumption. It was following all the proper water quality treatment processes, but that whole concept was new to the area. But they were so desperate, their lakes were gone, that they did not know what was gonna happen in the next 3 to 4 months. They were running out of water. How I talked about a safe yield, and that safe yield is 75,000 acre feet. That represents approximately about a 6-month supply, in the worst drought of record. So what happens when it's worse than worse? And that's what the situation they were in. So they were really looking at a direct reuse. Indirect reuse, which is a lot of the different communities such as Dallas, Houston, Austin, they use an indirect reuse where they discharge through their water treatment plant into a stream, and then they'll pick it up later through a diversion. So that is indirect reuse. If you go to, again, Houston, it's basically all the water coming down through Dallas, through the Trinity area. And then inside the city of Houston, they have multiple wastewater treatment plants. I mean, you're talking about a huge spread out city through Buffalo Bayou, through those areas where they discharge, and then later on down the stream, they'll pick it up, and then going through the same process, water treatment, same water, high water quality standards, they'll put it into their distribution system. But those are some of this is a big economic viable project that a lot of the cities in the state of Texas look at. Our issues here in the city of Corpus Christi, when we looked at it through economics, is this type 2 discharge. We have older water treatment plants. Those to get to a reuse that is feasible, we would need to invest a lot more into our wastewater treatment plants. And that comes at a big economic cost. Because you need to go from a type 1 to a type 2 to a type 1. And type 1 is where you can have human contact. Basically, type 2 is where you just discharge it into a water body, or you can, with proper notice, you can use it for irrigation purposes. We have a reuse system, and you can always tell reuse water because it's purple pipe. We feed water to a couple of parks in the area, and also some historic cemeteries, because that water can be, and it's good water, but to take it to the next step for reuse, for a potable distribution, you have to do a lot of economic investment so that you get over the hurdle of the type 2 discharge. Also, from an industrial point of view, because our industrial partners or industrial customers, we're really curious about how much reuse we could provide them. When we started looking into the actual chemistries, our water is a little saltier than the water that they would prefer. So the high chloride for industrial customers was a concern. Again, these are issues that always can be overcome, but they come at an economic cost. How much of the investment do you, the customers, want to engage to have this source of water? So it is a viable process, but the economics need to be looked at a lot more and weighed. Groundwater, or aquifer storage and recovery, is another project that the city of Corpus Christi is looking into. We have done a pilot, a pilot project on aquifer storage and recovery, or ASR. We're looking at the feasibility of it. We are one of the unique cities or areas in the state of Texas with groundwater versus surface water. It's kind of, again, apples and oranges. The city or the state has a very robust, long fought surface water laws under our water code. And then under groundwater, there's two types of legal areas that you can get into. You can go into areas where there's a groundwater conservation district that set up all the rules and regulations and the fees that are correspondent to taking or getting water from the aquifer, using it, to areas where you just have the largest pump rules. And so you could just put your pump down, and your neighbor could be right next to you, and you have a huge pump. You could draw all the water underneath his area, and it doesn't matter. So that's kind of the difficulties with a groundwater plan, is that you have to understand what are the locations, the water size, the aquifer size, the water quality, because again, Water quality of your source water is very important because that will tell you how much treatment and what type of treatment you have to do, which then therefore costs for that drop of water. And then also dealing with landowners is a big issue with groundwater and aquifer storage and recovery. So the city is again evaluating it. We have an area, we have our own aquifer storage and recovery district and it's basically the boundaries of the city of Corpus Christi, where we make the rules and regulations and we can control the water that's underneath us. And if we do a aquifer storage and recovery, which is basically a process where you put water down into the aquifer, you create like a bubble by pushing, and that bubble will push the native groundwater out, and then you're just, when you're not pumping the water down, and then you just pump the water back up, that source water that you put in would stay the same. That's easier said than done. But a lot of science goes behind that. But aquifer storage and recovery is again a feasible, economic, viable process from a water resource perspective to provide a new source of water. Okay, so we needed to, looking at all these sources, the city of Corpus Christi was talking about, we need to make sure that we know what's out there. Because again, these are just a few of the types of the viable kind of projects. So we just sent out what we call a request for information to developers, to prospective water purveyors, that if you have a good idea, if you have an idea that we have not thought about, please respond to this request for information. And we're getting a lot of interest from groundwater groups, from reuse purveyors that have companies and engineering firms that have an idea to help us with our reuse. They say that here's this idea of if you fix this plant in such a way that it makes it economically viable, because this is where your distribution system and stuff. So we're taking all those ideas right now and working through them. And they're going to answer a lot of these type of questions. How water moves through a system, what are the levels of the groundwater in your project area, that you can offer us. So this is an important step in determining a good or a viable project for our future. Desalination, this is the hot topic right now, and everybody is looking at the city of Corpus Christi to be a leader in seawater desalination in our state, and we have a great opportunity right now to be that leader. The city of Corpus Christi in this area has looked at desalination for a very long time, going back to the 80s. There's been studies. I've mentioned a couple of the studies that the city of Corpus Christi has gotten into, and we're finally at that step, the viable step of looking at potential sites and areas where we can get permits and and create a facility. What type of size of facility we're looking at? Working with our consultant, our owner rep, Friesen Nichols Inc. They're an engineering firm that was hired by the city of Corpus Christi to help us through the evaluation and the study of the seawater desalination. We started in really technically with a notice to proceed to them in July 30, 2018. So we're just at the beginning of this. We're looking at having a size of seawater desalination plant and approximately about 11,000 to 22,000 acre feet a year. That represents approximately about 10% of our water supply. So we want, again, all of these type of processes strategies are to diversify our system. Again, we are a surface water-based city. And a lot of the cities in the state of Texas are. But a lot of cities are diversifying their portfolio. And that's what we need to do. And this project will help us diversify it. There's a lot that goes into looking at a seawater desalination, and the scope of work that they're going to be looking at as our owner rep is pertaining to the Texas Pollution Discharge Elimination System, or TIP-Ds. That's basically the wastewater permit that you need to obtain for the discharge of the brine of that water. So in a seawater desalination plant, you usually get about 40, maybe between 38 to 40% recovery in the amount of water that you divert and then that you actually can use. So our total, what we want in MGD is about 11 MGD to 22 MGD of a facility. Our discharge would be twice that. Again, so we're going to work with our partner to get a TIP-Ds permit. TCQ has a diversion because it's a diversion of the seawater. It's under our water rights in the state of Texas, and we're going to work through these processes and working with our partners at the state level for the proper permits. So the project will focus on the location is the major component of this, because you always have to determine where am I going to put it. So we're looking at multiple sites, approximately around 5 sites, but at the end of the day, we would narrow that down to potentially 2 sites. Right now, the city of Corpus Christi, working with our partner, the Port of Corpus Christi, you may have heard in the news that they have applied for permits on the San Pat near La Quinta area, and also the Harbor Island area. They have permit applications with the state for the TIP-Ds permits, working through that process on properties they own. So they've moved a little faster in the process because they're looking at properties they already own, and the city of Corpus Christi doesn't own properties. So we want to make sure that we're picking the right sites. At the end of the day, those 2 sites may be the most viable economic areas, and that's great. They've done a lot of the hard work at the beginning to get us further along that line, and we thank them for that. But our project will look at approximately 5 sites, and then we'll narrow those sites down to the San Pat area, La Quinta area, and then also here on the Inner Harbor, the Corpus Christi side. And both of those areas, fit in with the whole economic and water resource idea, is to strengthen the viable water supply for the entire community. Working with the industry, working with our residents, it will help the entire water supply and strengthen that our diversion of our raw water. And so when looking at that in evaluation, these are some of the most important things that you need to do to evaluate the proper site. You got to worry about power. You got to worry about raw water quality. The source of water that you're bringing in. Again, what processes will I have to undertake to treat that water, and what are those going to be the economic costs or drivers for that treatment? One site may have a good water quality, and another site may have a bad water quality, but maybe it's closer to a distribution system, and treating that water quality, balances everything out. So those are the questions that through our process, it will evaluate on the siting so that we make this whole project work together. And that part is this integration into our entire facility. So I just want to kind of leave you all with the timeline of the project. You can see a lot of work has gone on. the city of Corpus Christi, for funding of this project, went out and got a loan from the state of Texas or Texas Water Development Board through their SWIFT funding. This is monies that the state of Texas has put aside into a large fund called SWIFT, and it's taken care of by the agency, the Texas Water Development Board, and you apply to them for different projects. Other communities from rural to large municipalities submit applications for funding opportunities, and these loans come at a very, very low interest rates for the state, or for the applicant, basically. I mean, they're almost our loan for. We applied for $2.75 million, and we're granted that. We pay up zero. We're going to pay, it's an 8-year deferred loan, and we're going to pay it at day one at the 8 year. You can't pay it real early, and they tell you, okay, 8-year mark here, this is when you start accruing interest and paying back. We're going to pay it right back on that day, so it's just like borrowing that money with zero interest. And this is the great economics that the state of Texas did in maybe about the 2011 timeframe, coming out of that. Again, I know I sound like a broken record, but everybody thinks about water and how to pay for water when those droughts occur. And those droughts occurred, and every legislator in the state of Texas was all about water. How can we fund it? How can we move water from different areas, change rules, change this? And this is one of the things that came out of it that will provide for our future. And it's a great opportunity because it's my tax money, it's your tax money that goes to it. Why shouldn't the citizens in this area benefit from that fund? So we're taking advantage of that. We also, we have to work with our city council and do a lot of presentations and get their approvals on this project, and they're right behind us, and they're encouraging us to move on, and they're supporting us really, really, really well in this project. So it really kicked off in about November of 2017 when the city council approved the notice to proceed. But then they also wanted to make sure that we were on the right track. So about May of 2018, they decided they wanted to come back and I had to give another presentation and exactly talk about what we've done, what is the process, because at the same time there was a lot of moving pieces to this puzzle, and they want to make sure that we're on track and we're moving forward with this. So we got approval again to go ahead. You can start working with your consultant in May of 2018, and then by the time engineering and it takes about a month because they got to get their people together. These kind of projects, they take time. You're going to spend a large amount of money right now, and then you're going to even spend a larger amount of money when you're going to build the plant. You want to make sure it's right. You got to get it right. So that's why by July 30th of 2018, we gave them the notice to proceed. We got the good scope of work, and we're moving forward from there. I just had meetings up in Austin yesterday, talking to our partners up there, TCEQ, Texas Parks and Wildlife, to have them understand where we're coming from and how we're going to supply our community and our customers. Because again, this is about us. This is about our community, and everybody is not just a customer, but we need to work together for this water supply, because it's gonna affect your children, my nieces and nephews, forever. These things are gonna last, and we got to get it right. So we're hoping that we'll complete the project in, I say August of 2020, but it could happen earlier than that. Again, construction and planning, the dates kind of change. But that's kind of like where the last update I had for it to end. So it's coming soon. It really is. I'd like to thank y'all for this opportunity to come speak to y'all. If y'all have any questions, I'm more than happy to take it. Yes, sir.
Yeah, one of the things I've always been concerned about is the Choke Canyon, the high evaporation rate that you have there, and yet you've got Lake Corpus Christi. Why don't you maintain Lake Corpus Christi as a constant level lake so that I understand we lose like the entire use of Corpus Christi per day evaporation from Choke Canyon. So why don't you just maintain, instead of wasting that water to evaporation, bring it in and put it into Lake Corpus Christi and have a constant level lake like other lakes do here in Texas.
So the question is about trying to keep Lake Corpus Christi as a constant level lake. Lake Corpus Christi, we typically keep the lake around 80 to 90 percent full. Well, that's in a perfect world. Remember, if we're in a drought, we don't have where it comes in from. It's difficulty to do that. But to get to the reasoning why to move water from Choke Canyon to Lake Corpus Christi, there's about a 40 to 50% loss.
But you have 100% loss.
So we could keep more, and Choke is a lot bigger. So you have a lot of the water that is in Lake Corpus Christi to supply our water downstream through a balancing effort. With fighting evaporation, I mean, the lakes are where they are. I can't get a lake and move it, and it is what it is on that sense. We do move about every day out of Choke Canyon, 27, 29 CFS is moving through the lake. But again, Choke Canyon is a larger lake. To keep that water in that lake, you also have to have water in there. So that it would help with the evaporation. So it is very rare in the state that you do have constant level lakes, where this lake is a municipal supply reservoir. Lakes like, even if you go to Lake Buchanan, the Highland Lakes, they are not a constant level lake. Another big example of a non-constant level lake that everybody assumes is a constant level lake is Lake Medina, that feeds the Medina area where we get all our vegetables and stuff like that. It's for agricultural purposes. So that lake comes down, up and down with needs. And that's the same sort of, those reservoirs are for municipal purposes. And so the amount of evaporation that we lose about maybe 50,000, 60,000 acre feet. We just made 50, 60,000 in September. So at the end of the day, when you look through the time, it will average out in a normal year. Now, when you argue the point of a drought time, droughts are droughts. And evaporation, you're gonna lose it if you had it in Lake Corpus Christi or if you had it in Choke Canyon.
Not the same rate.
At almost the same rate.
You got a smaller area.
In the area, you have a smaller lake, and it's not just how the evaporation, it is how the construction of the contours of the lake. Lake Corpus Christi is not very deep. It's a very shallow lake compared to Choke Canyon. So the water is a lot warmer a lot of the times than Choke Canyon. So there's a lot of factors that go into the balancing of that. Yes, sir.
Yes, between desalination and recycling of water, which process might be expensive?
The question was between desalination and recycling, the reuse. When you say recycling and reuse, it's amazing when you look at desalination through the history and going back, the technology has gotten better and better. So the price of the materials that you use for desal are coming very close to what our reuse costs would be. So right now with desal, we're looking potentially around $3.40, $3.60 per thousand. That would be a perfect range. Water treatment, it's going back to how much of our water treatment plants need to be upgraded. And those costs could match what the desal plant would be. And the O&M costs are the same too. Because you gotta, also with a desal plant, it's an easy technology because we're gonna use what they call an RO, or reverse osmosis, where you take high pressure and you put it through basically a filter and you take out the salt, right? And that's a very simple description of it. And then treat it, because you have to still treat the water to a certain standard before you either put it into your distribution system, or if you go for an industrial, straight industrial, you still have to do some treatment. So you're gonna have a small kind of a water treatment plant. So the costs can be nearly the same. Through this feasibility project that we're gonna do, we're gonna answer those questions that you're talking about, so that we can understand how much that cost of water will be. Yes, ma'am.
How much does the TPDS permits cost? Like you said, you have to go through like a series of permits. How much does that cost?
There are the question is how much the cost for the TPDS permits, the TIPDs permits. There is a small administrative cost to the state to evaluate that. The real cost is coming through the actual application process to fill out the applications. And that could be, again, we're looking at potentially 2 TIPDs permits, and the cost of obtaining that with all the other studies, we're looking at about 2 million. So within that, maybe around, maybe a third of that, 300,000 for just the application. So there is a cost, because there's science. You have to do a lot of modeling. You have to do a lot of outreach. You have to do a lot of communication with the states, so you know what you're filling out, how they want to see it, what the science behind that, because you have to get the right data so that they can do the proper review on the application.
Once y'all receive that loan, the slip loan, that $3 million, almost $3 million, who pays that? Y'all are paying it back at one time, but does Corpus Christi have like a separate fund for that water project, or is that what you're creating?
So yes, so the city of Corpus Christi, we will pay that loan off back to the state. The funding that we have on everybody's bill, we take about 5 cents from your overall water consumption, and that's industrials, that's the wholesale, everybody. We take about 5 cents for new water supply projects. And that fund, we have a raw water development fund that helps pay for these projects, and that will help to pay the loan. I'll come back.
The ratio of loss with desalination versus reuse, is it similar? Because you said you only get like 30-40% of the water that you put through desalination you actually use. So is reuse higher or lower?
So if I understand your question, what is the difference on the loss? So if you use, as you use more water in a bigger plant, the recovery gets better. But those economics to get to that bigger plant are a lot more initially.
So right now, like the our plants that we do have versus the idea of the desalination, is one better or one worse on how much you're losing real water?
So the percentage, the question is water loss compared to what our raw water intake right now. We have our surface water, so you're taking 100% of that water into the plant, and we basically, if we take in 60, we're putting 60 MGD, we're putting out maybe about 50. So that's just, we have very little loss in the water process within the water treatment plant. But with desal, it's taking that water through high pressure, and you're going to have some of that water that has to go back out with the discharge. In a conventional water treatment plant, you don't have that. So that's where the extra loss comes in. Yes, sir.
Yeah, there's, as far as I know, there's only 2 saltwater desalination plants in the United States, and they've been pretty much a disaster. And for example, the one in California was supposed to cost about $400 million, now it's at $1 billion. And the Tampa Bay one has been gone bankrupt several times, and they've had real problems with it. Whereas if you go to, instead of going and using the seawater, we got this thing with disposal of it. But if you go and why not go to the Gulf Coast aquifer there and get that, the low salinity water there and treat that one? And that's going to be at about 1/4 the cost of doing the saltwater. The saltwater, you got 35 ppt, whereas the other one, you got 5. And so instead of using, you can use about 200 pounds pressure with the desal with the brackish water as compared to about 1,200 with the seawater.
So the question was about comparing brackish desal versus seawater desal, and the issues in the past or other facilities in the country that have gone down a seawater desalination process. And you're right, there are lessons to be learned from other locations in the United States, and we're working with our consultant to take those lessons learned, and that's what you should do, and that's what this project will do, is evaluate those lessons learned from those other projects in California and in Florida with Tampa. And a lot of that came out of the, I would like to say, peripheral economics that are involved in a plant and construction, dealing with land ownership, rules and regulations, and the funding mechanisms that you have to facilitate the loans or the banking of a large project such as a desalination. And those types of issues occurred. And the procurement part is a major part of understanding how you do a desalination plant correctly. The whole world is doing desalination every day. There's many plants in Israel, there's many plants in the Middle East, there are a ton of plants along the Australia, along the Gold Coast area. Friesen Nichols has one of the most well-respected consultant on their team, on our team, to evaluate this. So we got a lot of good people, a lot of strong people that have worked in desalination working on our project. With respect to the question about differences between a brackish groundwater project and a seawater desalinator project, it also comes down to the infrastructure. Infrastructure for distribution, connecting into a distribution system, can be as much as the plant itself. And moving water from one place to another is a large cost. In this area, that same brackish water, is it available? What are the quantities available? What are the reliabilities of a brackish desalination plant? And then at the same time, you're talking about the unknown questions of subsidence that you could occur in a groundwater brackish desalination plant where you're taking a lot of that out. You know, the city of Houston, that area that has a lot of subsidence and that. So those are some of the issues revolving around a brackish groundwater type of desalination plant. There are many brackish groundwater desalination plants in the state of Texas. There are very few seawater desalination plants in the state of Texas. Brownsville has looked at a seawater desalination plant, but they're not online. The M&G plant here in Corpus Christi, from an industrial point of view, has a desalination plant, but again, they're not online through economics and the bankruptcy of that particular company. So it is a new technology to us. It is not a new technology to the rest of the world. And again, these are a lot of pieces to the puzzle that our study will look at and have answers. We're at the beginning of this thing, and we need to work through the project so that we can answer those questions correctly, so that we can, when we get to the point of saying, okay, it needs to be here, this is the cost, this is what it's going to be, we know what we're getting.
One other question too is that the other worlds, the other places that have the seawater desalination, they are right next to the coast. And let's say if you put it on Harbor Island, to get rid now, what they do is they have a pipeline going at least 6 miles out into the ocean. Otherwise, what you'll do, you'll kill everything in the bays. So if you put it on Harbor Island, that means you would have to have a discharge to get rid of the excess salt to go underneath the ship channel and then go through under Padre Island and all that. Whereas if you went and built it on Padre Island then, or something like that, then you don't have to go under the bays, you don't have to go under the ship channels and all of that. You've got to get rid of that discharge. You cannot dump it into the bays.
So-
You kill everything in the bays.
The question is about discharging into the bays and the issues evolve around that. You know, through our feasibility study, looking at the sites. Again, when I went over and talked about that site location, siting is going to be very important. And when we do go to the state of Texas and obtain those discharge permits through the tip Ds, we have to follow all the rules and regulations that the state has us under for that application. There are, what they use is a core mix modeling, and that information talks about what are the water quality, what are the depths, where the strata, how the water is stratified. You know, all that goes into the modeling and the questions in that application, because you want to make sure if you're discharging that you have the correct mixing, and that's going to be one of the questions that through this process that we answer. And some sites are going to be better than others, and that's going to lead us into saying, okay, this, if we put it here, you can do it, because at the end of the day, engineers can do anything, but it's going to come at this much of an economic and community cost. Is it worth to you? You know, those are the things that we have to answer. So that could say, okay, we have this other site where it's better. It integrates into our system a lot better, lowers the cost, lowers the mixing is good, all those questions. And so that site would win. So when we want to find the best place that we can integrate it into our system for our customers. And those type of questions through our process will be answered. So that's why, you know, I think how the city of Corpus Christi is doing it is the proper way of looking at everything, so that we can make sure that we're answering question A, question B, question C, so that we can communicate. Because again, at the end of the day, we all live here. We're going to be living. This is city of Corpus Christi is not going to just disappear and say, oh, because of this plant. We're gonna be responsible for this plant in perpetuity. Yes, ma'am.
I know this may sound
No.
silly, but then I'm just wondering if I missed something. What makes the desalination plant a better option versus just recycling water? If the loss is greater with desalination versus reuse, and they cost about the same to like update our plants, what's the profit? Like, did I miss something?
One of the things is the quantities. We don't discharge. The question is about. The question is about compared to why aren't we looking more at reuse than desal if the return on the quantities are there. It also has to do with the quantity of reuse water that we're pushing out. Our plants are really not pushing out that much water. We could do, the city would have to consolidate a lot of our water treatment plants so that we could get to that same number as one desalination plant. So that cost would be more than just one desalination plant, because you're talking about moving, 5 wastewater treatment plants down to one. And it's just not the plant, it's all the infrastructure that goes on underneath the ground that no one sees, and the cost for that. So those are some of the factors that when you're evaluating between reuse and desal are another project that you have to evaluate.
The biggest desal of using brackish water is in El Paso. That's the plant there. And then we have the one in Florida that uses seawater. Has anybody from Corpus went and visited those desal plants and then asked questions that maybe they should have asked before they built the plants?
So the question is, have we visited or talked to other communities such as El Paso or Tampa or other places in the United States? Yes, members from management have gone. Again, this process has been going on since the early 80s to today. So there has been a lot of work behind the scenes to make that evaluation and talk to all the right people. With respect to the El Paso plant, it's a brackish groundwater. That's kind of their source. It's not their whole source of water. They take a lot of water from the Rio Grande up there, Elephant Butte, and that's a lake in New Mexico that sends them water. And so the diversification of the water supply is important. We've also talked to SAWS, or the City of San Antonio Water System. They have a very diverse raw water resources. They have sources from aquifer, from the Edwards to aquifer storage and recovery, and they also have a brackish desalination plant. We took a tour of that plant, and they also have a Vista Ridge project where they take another groundwater source from kind of the College Station, Burleson County area, and they're going to transport it through a pipeline just like ours up into the northern part of San Antonio. Their projects, they have spent on just the Vista Ridge a little over $1 billion on their project. Could we do $1 billion project? I don't think so.
Yeah,
We need to look at the economics again that would fit our area.
their desal plant that was supposed to cost $220 ended up costing $290 and didn't produce as much water as what they thought it was going to produce.
And it's expected to produce as much as they actually did, but at the same time, their needs are driven differently than our needs. They're just looking at it from a drought perspective. They are banking. They do a lot of banking. They'll spend billions of dollars and just put it to the side. And what they actually did from an economic point of view is on everybody's rate in San Antonio, they just give you $10. They put a $10 bill on you, plus their water rates to pay for these projects. So the economics behind these projects are vast, and we have to do the right science and we have to do the right steps, and we're at the beginning of it. This is a great project. Again, I'm more than happy to answer any of your questions offline. I really thank y'all for having me here.
Well, wait a minute, I have one last question, I get to ask one.
No.
Since I invited you. Has there been any consideration, since the ExxonMobil plant and the industry in Santa Pat is fairly close to La Quinta and to the ship channel, of making the desal plant only treat the water up to industrial standard and not potable water, and then build a separate distribution system just to supply industry, rather than, as you explained to me beforehand, that when you have pipes from a water plant, you have to have it up to potable levels for residential and for industry.
So the question is, have we looked at the purpose of use for the water coming out of the desalination plant? If compared, the two purposes of uses that you would use it for would be for industrial purposes or for potable purposes. And it goes back to the siting question. And it goes back to what infrastructure that you have there that would better be integrated. If a plant is built on the San Pat side, San Patricio County side, it could be a better idea to do industrial use. Working with our partner, San Pat Municipal Water District, they have the infrastructure to supply water to customers on their side, because they are our customer, and then they feed a lot of the large industries and communities on that side. So they have that infrastructure over there to only take water to certain industrial users. So at the end of the day, if we do decide economically, viably, that a site would be better on that side to start off with, or the second site to start off with, that could be an example that we would go to an industrial grade water rather than a potable grade water. And that would change the economics and the cost of said water, because you wouldn't have to account about it. If you have to build new pipelines to distribute everything, then all those variables change, and you have to evaluate that at that time. So.
Okay, thank you very, very much.
Thank you. Thank you.